Good morning, class 8. Today we'll be starting with a new lesson number 13, sound. What is sound? Sound is a form of energy that can be heard and it travels in waves. So, what happens when anything vibrates or moves back and forth due to some force applied on it? It makes a sound. Okay, so it has to travel. Sound is produced in one place, but you can hear it at a different place, isn't it? So it means that sounds travel from one place to another. Can sounds travel through solid, liquid, and gases? Yes, they travel through all different mediums, isn't it? So this is sound. So what is sound? Sound is a form of energy that can be heard. In simple terms, we can say that sound is a sort of disturbance. Can you see the picture here? What do you see? Probably somebody has just thrown a stone in the calm, still water, and where the stone has hit, there is a disturbance. And we can see this disturbance, isn't it? Something similar to this happens in the air, in the solid, in the liquid. Okay, but since this is a liquid, we are able to see this easily. But when this happens in the air or in the solids, we are not able to see this disturbance. And you can see the waves traveling, isn't it? The waves get bigger and bigger and travel from one place to another. Sound waves also travel in a similar manner, but not like this, not in a concentric manner, but in a longitudinal manner. So, how sound is created? When you hit an object with some force, can you see the object on your left? Okay, it's a fork. We call this a tuning fork. It is a common device used to produce sounds in a physics lab. So it's called a tuning fork. You hit the tuning fork on a hard object like a desk or a wall. What happens? The fork begins to vibrate, it begins to move. And this movement or vibration or to and fro movement causes a sound. All the musical instruments that you hear, okay, which produce wonderful music, have some part in it which vibrates. But in different musical instruments, we have different parts which actually vibrate and produce the sound. Let us take some of the common instruments. For example, the veena, a common musical instrument used in Carnatic music. So, what is the part that vibrates here? It is the stretched strings. In the sitar, which is a Hindustani classical instrument, again it is the string. In a violin, again it's a string. The tabla. In tabla, it is the membrane, a thin skin, which is right on top of your tabla. When you hit that membrane, it vibrates to produce sound. Same is the case with mridangam, the drum, the dolak, anything that you hit, it will vibrate and produce a sound. All these instruments are called as percussion instruments, whereas the instruments with string are called as string instruments. The third category of instruments are the ones which you blow, isn't it? The shehnai, the flute, the mouth organ. Hmm? All these instruments, you actually blow the air and let the air move through different columns. And this is what helps to produce the sound. So, Now we have established that sound is actually a disturbance which travels. So, do they travel in all solid, liquid, and gases? Yes. The answer is yes. Yes. Sound travels in solids, liquids, as well as gases. But at what speed is the speed same? No, the speed is not the same. Can you see the picture? In solids, the molecules are tightly packed. So, if you have a domino effect, the speed with which the cards will fall will be higher. Similarly, sound travels fastest in solids. You see a huge gap between the cards or between the molecules in the gas. So, this slows down the uh, traveling time, and in gas, the sound travels the least. Okay, so it is the slowest in the gases and it is fastest in the solids. So, what happens if I don't give any medium? Okay, let's understand this with the help of an experiment. What I have here is an electric bulb which I have placed in a bell jar. Okay, to this bell jar, I have attached a vacuum pump. So, I let the electric bell ring by attaching it to a electrical point. And while the bell is ringing, I use a vacuum pump to take out every bit of air in the bell jar. So as I begin to suck the air out, I cannot hear the electric bell. You can do a similar thing using a straw. Okay, you may not have a vacuum pump at home, but you can surely suck the air out of a small paper tumbler or some device like that. You can try this experiment out at home and verify for yourself. So what does this prove? This proves that sound needs a medium to travel, and sound cannot travel in vacuum. This is the reason why people who go to space, they cannot hear. Okay, even if you speak, one cannot hear in space. Why? Because there is no air there, so sound cannot travel in vacuum. How do humans produce sound? We have established that sounds are produced due to vibrations. Then how do humans produce sound? Humans make sounds due to a wonderful organ present in our throats, which is called as the voice box or the larynx. You can see a picture of it there, right there. Okay, so it's a cartilaginous structure with two stretched membranes, which we call as the vocal cords. The vocal cords allow different types of air to travel in between, and it vibrates to produce different kinds of sounds. So the vocal cords present in the voice box or the larynx are primarily responsible for the sounds that human beings produce. Now we have established how we make sounds. Let us understand how we hear sound. Okay, so we hear with our ears. This we were taught in first handed. Now let us understand a little bit more about how the ear works. We can divide the ear into three different parts: the outer ear, the middle ear, and the inner ear. The different colors in the picture will help you to identify the different parts. So the outer ear is orange color. It consists of the ear pinna and a long tube. At the end of this tube, you will find a stretched membrane which is called as the tympanic membrane, or in simple words, the eardrum. When sound is carried from the pinna right into the canal to the eardrum, it begins to vibrate. In the middle ear, you can find three different types of bones. Okay, the bones are interlinked with each other and on one side are also attached to the eardrum. So when the eardrum vibrates, these vibrations are passed on to the series of three bones. The middle ear consists of certain canals. Okay, so the middle ear consists of semicircular canals, and there are auditory nerves in it. So these vibrations from the middle ear reach these canals and are picked up by the auditory nerves and carried to the brain. This is how we actually hear. Okay, so these are the parts of the ear and how we actually hear. Any damage to any parts of the eardrum or to the canal or to any of these bones will actually um, happen to have a hearing loss. Okay, so we may not be able to hear if we damage any part of our ear, and the eardrum being the most important. So this is the part 1 of your sound lesson today. I want you to do a small activity. Here is a small, a very simple one string instrument called the ektara. Okay, I want you to make this instrument, play it, and make a small video of it and send it to me. On the other hand, if you are not interested in making the ektara, you can make a jal tarang. That is what you see on your right hand side. Collect a few different sizes of vessels from your kitchen and fill them up with water. If you take glass balls, the sound is going to be wonderful. Okay, then take a wooden stick and try hitting these bowls. You can hear a beautiful sound, a musical sound, and this instrument is called as the Jal Tarang. Okay, so make either of these instruments, any one, any one of these instruments, and you can upload a small video of you playing these instruments before the next class. Okay, that's the activity for this lesson. We'll continue this lesson in the next video that will be aired next week.